All right, welcome everyone. Thank you so much for joining us today for this webinar, which is a panel discussion with Thomas Wosch, Olivier Lartillot, Bastian Vobig, who will be presenting about the human interaction assessment and generative segmentation in health and music. As an attendee, please use the chat to introduce yourselves, tell us where you're from, what do you do, is it music therapy related? The very last point is we invite you to join our newsletter so you can be up to date with CIMTR research and upcoming CIMTR lectures. Okay, now I'm going to hand over to Dr. Clemens Maidov, Senior Research Fellow at the Cambridge Institute for Music Therapy Research. Thank you.
Yes, hello, and thank you all for coming, and also welcome from me. I'm Clemens Maidov. I'm a Senior Research Fellow here, and it is my pleasure to introduce our guest speakers tonight, which we have three of tonight. So there's Thomas, Professor Thomas Wosch, Professor of Music Therapy at the Technical University of Applied Sciences in Würzburg-Schweinfurt in Germany, where he leads the Music Therapy Master's Program and heads the Music Therapy Lab at the Institute for Applied Social Sciences. He's also involved in several national and international research projects, including HomeSite, Midel, Music Moves, DigiMoose, and HIM, focusing on dementia care and automated music therapy assessment. And of course, he's well known for developing microanalysis in music therapy. Then we have also Olivier Lartillot, who is a researcher at the Center for Interdisciplinary Studies in Rhythm, Time and Motion at the University of Oslo, Norway. And Olivier focuses on computational music analysis and artificial intelligence. And he worked with Wosch Erkkilä and Petri Toivainen and developed the Music Therapy Toolbox, as well as the MIR Toolbox, a recognized tool for music feature extraction from audio. And he also developed the mining suite, an analytical framework that integrates audio and symbolic research for comprehensive music analysis. And finally, we have Bastian Vobig, or Vobig, as Leo said. I'm not sure, but it was, yeah. But he studied musicology in Würzburg in Germany as well. And since 2022, he contributed as a research associate within the HIM project. And he's also a research associate at the Nuremberg University of Music, where he started his PhD projects analyzing autonomy in music therapy improvisations. And his current research focuses on the interdisciplinary modeling of musical interaction and the integration of music therapy analysis methods into sociological and digital frameworks. So yeah, thank you all for coming, and we are very much looking forward to your presentation. And with that, I'll hand over to you.
So thank you very much for inviting us here, us three, for the public lecture series of the Cambridge Institute for Music Therapy Research. It's a great honor for us to present here and to present it to the world, as we can see here in the chat, where you all are from here. And it is really perfect moment in time now. We have here to present the in-between, but the most important results from my point of view from our HIM project. And so please, Bastian, to the next slide then. And here, for 15 years now, we worked on the automatic assessment of musical interaction in clinical improvisations. We started together in 2010, together with Olivier Lartillot and a group of 3 researchers here in Würzburg to develop such a tool there. And in between, we made some progress. I will tell later a little bit about the next steps we did. But now the very good and important outcome we have now is our HiM project, and this is a scholarship, their PhD scholarship, which is done by Bastian Vobig, who will present in a minute these steps and results there. And we have now a tool for clinical practice there to analyze the musical interaction. And this is very important and a large step Bastian did here, and we will explain and talk about in the next minutes together here in our open lecture.
So coming possibly to the project aim first. So where did we start? The starting point was basically on mainly studies by Wosch Erkkilä in 2011 and 2021, investigating that integrative improvisational music therapy, or short IIMT, is effective in the treatment of depressive disorders. So IIMT, short, is like basically alternating between speech therapy and improvising together, so dyadic improvisations between therapist and client, and to kind of use those multitude of informations resulting from those improvisational settings. There are several assessment methods one can use. And one method that we are currently using is microanalysis. And microanalysis especially enables in-depth assessment of music therapy improvisation sessions, as it analyzes data in general, or musical data especially, with very, very small time frames through the whole improvisations. But this kind of detail has one caveat, and this caveat is that the application of microanalysis in clinical practice is unrealistic due to the high time expenditure and training requirements needed to apply microanalysis. So Thomas told me once that one microanalysis of one improvisation lasts for about a week in total, which is not possible for clinical practice. So therefore, our project mainly revolves around automating microanalysis to make it available for clinical practice and to make the results even more precise on this microanalytic level, and reintegrate those results back into science and the clinical practice for music therapy. So summarizing it, we aim to support music therapy assessment by developing an automated tool that analyzes musical interaction types in clinical improvisations. How are we doing this, or what are we doing this with? We have a data set that is provided to us by a study of Wosch Erkkilä in 2021, investigating the effectiveness of listening homework and slow-paced breathing, in addition to ordinary improvisational music therapy. And from this study, we have data consisting of MIDI data, audio recordings, and measure scores, so depression scores, of dyadic piano and djembe improvisations of 70 participants in total, all of them adults with a primary diagnosis of a major depressive disorder, whereas no musical skills were required from the participants, and each of them received 12 biweekly sessions of IIMT. So by using this, we have quite a large corpus that we can work with, especially in thinking about machine learning processes. How are we doing this? So I'm giving a brief overview of the methods that we're using, and afterwards we go more in depth about the methods and how they actually work. So the methods we're using basically are triangulation of the IAP-AM, so improvisation assessment profiles, autonomy microanalysis, the music therapy toolbox, or short MTDB, and the SGT, so the social systems game theory. And each of them kind of fills a different role during this research process. So the IAP-AM is the qualitative center of the system. It classifies interaction into 5 or respectively 6 different classes. Thomas will talk more about the development of IAP-AM and why 5 and 6. And it classifies those interactions into dependent type, follower, partner, leader, resistor, and independent. The MTDB, as already mentioned, developed by Olivier, is a computer-automated music analysis tool for MIDI files, and it gives out measurements like statistics or rhythmic periodicity and others over time, and is tailored for music therapy improvisations between 2 players. The SGT finally is more a framework for decision-based social interaction. It helps with formalizing roles and action possibilities, and it structures the actual interaction process. And from this point on, we go more in depth with each method, starting with Thomas with the improvisation assessment profiles, autonomy background.
Thank you. Next slide, please. From my point of view, the godfather of improvisation assessment is Kenneth Bruscia. So it's incredible. His improvisation assessment profiles, they're developed in 1987, are taught until today, are worked with this until today. And this is really very profound and very long-term outcome and tool here for music therapy assessment. In our microanalysis book, we had in 2007 4 microanalysis based on the IAPs there. And also in the Nordic Journal for Music Therapy, we had special issues on IAPs. We had it in voices and so on. So this is the basis of it. It came from clinical practice, but seems to be really stable and really long-term valid observations and categorizations of clinical improvisations. So next, please. One reductionist approach of this did Tony Vikram in the use of the improvisation assessment profile autonomy and the profile variability, and he used it there in Harper House in London there for the diagnosis and assessment of communication disorders of children with autism spectrum disorders there. And so this was the first step of the reduction to make it clinical applicable there for the assessment purpose there in clinical practice. And then next. Next steps from my side were to further develop the improvisation assessment profile autonomy to a microanalysis. And this means to see second by second what happens there in the clinical improvisation and what microprocesses can be measured there with the autonomy profile, but in the micro version. I will explain it in a minute. We worked since 2010 there together with Olivier, with also data from Wosch Erkkilä's first study on outpatient depression treatment there, and further developed the music therapy toolbox together here in Würzburg with Katrin Gruschka and Anna Jonscha there. Then we keep going with Wosch Erkkilä there to have the liaison, the marriage of music therapy toolbox and the aural-based improvisation assessment profile autonomy micro there. And then finally, I could be successful in a call in the Bavarian high-tech agenda there to get the money for the scholarship and additional money from our university, from University of Music in Nuremberg and the Bavarian Graduate School Health there to make it work, the further development for the automatic tool, and still in collaboration with Olivier, but now not in Jyväskylä, now in Oslo, there in Norway, there, and to work and develop this together. And it is done also in the collaboration with the data from Jyväskylä, as like Bastian said there, and also with the University of Music in Nuremberg. Okay, so next, please. The improvisation assessment profile of Kenneth Bruscia was mainly done to find the categories of the autonomy profile of the role relationship of the client there in clinical improvisation, and it assessed the whole improvisation and did rate from dependent to resistor in 5 different roles. Then I did some changes and further development. I included the client and the therapist in the measurements there of the autonomy profile. I did then the continuous measurement there, second by second, through the improvisation. And so that means that each change can be seen. You will see in a minute, like we did this. And each change of the interpersonal relationship in music was analyzed or measured here. And we did add a 6th gradient there, the independent category, because when we did the assessment of clinical improvisations of children with developmental disorders, especially autism spectrum disorders, we could see that there was also not, if they do different musical behavior from, for instance, the client does, it is not all the resisting musical behavior. It can be also an independent musical behavior. And so in a way, we completed from dependent to independent these categories there, and had also special definitions of the independent role there. Okay. And then you can see it in an aural assessment. There, second by second, we did assess this in the main categories of rhythm, of melody, and of timbre. There, and timbre includes also the volume and also the attack, for instance, and so on. And melody did also include then the harmony, and rhythmical basis, also rhythmical patterns and tempo and so on, there, meter. And then when one is starting, for instance, here's a therapist with T, then for the first 6 seconds, therapist is the leader. And when the client joins, then thereafter, second 6, then the roles are changing. And I will explain it more also in the next slide. And so each change is then written down as a new second. Yes, please, the next. And then you can see here also this in the rhythmical basis, melody, and timbre there. And what we did now in high M was also to compare there the features and the results of the music therapy toolbox. And there was a further development. Bastian will explain in a minute. And there, for instance, in the beginning, the therapist played for the first 5 seconds there in mezzo forte, in the middle loudness, and then also there in just 1 minute, then in a clear melody, and there also in clear tempo. And then the client joins and does not meet their then just a minute, plays another meter, and so it's not following and joining the therapist, so it is there's a resistor role. Then in melody, it is in same harmony and following the melody categories of the therapist. Their client is the follower. And then in timbre, client is playing louder and with sharp attack there. and articulation with sharp articulation there. And so it is the resisting role. And so second by second, it is there described, but it is very important to have this list. You can see here what does made the change and to be the resistor follower partner dependent or independent role in a musical way. Okay. And so, in the end, with the contribution of the IAP autonomy micro there, in the Bruscia's autonomy profile, it was the follower role, for instance, was defined that the client consistently takes the follower role more readily than the leader role. So, for instance, a client is offering rhythmic and melodic grounds more than often than figures. So the mean of the occurrence of special musical features is here important in the Bruscia profile and defines if the client is follower, leader, and so on. And we did then the observation there in also with help of music therapy toolbox there, and came to an inductive approach and did it for each change. So, for instance, the following tonality of the other is then the following role, or to adapt to the volume or articulation of the other is then there also in timbre the follower role, and so on. And so these features and formalizations are there identified, Bastian identify as the affirmative movement there from, for instance, here medium distance towards closeness, so that proximity is an important feature to analyze there, also in the digital data of the music. And we had sometimes the challenge that the music therapy toolbox, for instance, in timbre, did differentiate in articulation and in the volume there, for instance. And so in one subcategory, it was the one role, in the other role. So even the digital analysis provides here more details and made us that we had to find decisions what is here the majority and the main feature. But this was all done in the digital analysis way. And so for the next step, I hand over to Bastian and to Olivier.
Yes, hello, I'm Olivier, so developer and co-designer of the music therapy toolbox, MTTB. So we, next slide please, we started developing this MTTB as part of a project which was called Intelligent Music System in Music Therapy, led by Wosch Erkkilä, preprocessing. It was 2004. It was my first postdoc, my first time I was in Finland. And so based on this same idea of two-player improvisation using Bruscia improvisation assessment profile, and we thought it was important to have some computational tools to analyze the music to help getting those kind of profiles. So it turns out that at that time, my colleagues released already a MIDI toolbox for analysis of MIDI features and audio music analysis from MIDI. Which require MATLAB. So it's a kind of layer top above MIDI toolbox, this MTTB, with some focus on music therapy and some additional feature. Next slide, please. So basically, it's about the computing temporal features, evolution of different type of features along time. So you have two players, so you need to have MIDI file with two MIDI channels for the two different players. And so we compute analysis on short windows of 6 seconds by default. And the window moves a long time along this two-player music. And so we get, so for each position of the window, we compute one statistics. So for instance, the first feature you see here, the first set of curves, mean pitch, so the average of pitch in that window of 6 seconds. And so then you compute this once, you move the window 1 second every 1 second, and so you get a curve. For instance, here we can see the client's mean pitch is much higher than the therapist's mean pitch, and so on. So I can directly, can go to the next slide to see the list of features that was proposed, that is proposed, and you have a graphic interface. You can select the features that you want to choose. And so let's say we start with the first feature. The first one, node density. So in the window, you see again on the top, the piano roll of the two players. You see the time frame from 0 second to 260 seconds. And then you have the 5 features, so starting with density, node density. So how many nodes in each window, so giving the indication of how many nodes they play over time. And you can see that, for instance, that the time is a bit different time indices for the curve. You can see at the very bottom that it starts from 40 to 260, so it's a bit different. But you can see that when there is a high value for density, it corresponds to where the players play a lot of notes you can see the piano roll. So then you have the second features, duration of the notes, then mean pitch, so which indicates the kind of general pitch curve of for the different players, the two players. Then pitch standard deviation, so the variance of pitch. So for each second or the window of 6 seconds, if the player uses a different register at the same time, so that will give the high value for the pitch standard deviation. And the last one here, velocity, in MIDI terms, it means dynamic. So from pianissimo to fortissimo. Next slide, please. Let's go quickly. There are some attempt to have some kind of tonal analysis, so degree of whether it's very tonal or not, major or minor. But of course, in some contexts when you have a non-expert musician, maybe it doesn't. So it's maybe not so interesting. So maybe we can go to the next slide with this time rhythm. And you have pulse clarity, how clear is the pulse, so that's the first curve here. Then articulation is whether you have silence between successive notes or not, so it's like between legato and staccato. Then the tempo in BPM, I will go back to this if I have some time on the next slides to mention about this problem. But here, the last two features here, it's about synchronicity between the two players. So an attempt to see if they play at the same time and which tempo. Then on the next slide, it's something additional. Not only you have curves, but we can also detect when the two players imitate each other. So you see here is this example that the two players on pulse clarity, they increase and decrease kind of at the same time. But the red one is a bit leader for this ascending part at the middle. And so at the bottom, we try to build this kind of imitation diagram. It's based on like correlation, window-based correlation function. And you see like yellow clouds when you have this kind of imitation between players. But I guess we don't have time to go into detail in this, but we are not using this for the project here because we wanted to go into more details. So next slide, please. This figure that you just show is part of one of the latest publications. We was collaborating with Clemens Madoff and other co-authors on a paper in forensic psychology using MTTB with EEG data. But you can see other publication here related to MTTB. And next slide, please. So then just to finish this difficulty with tempo, you could see the switch from 60 BPM to 100 BPM. Of course, you have the different metrical levels. So next slide, please. The problem is that, of course, when you have pulsations, you have a different range of pulsations. So if you play a 16th note, let's say, you have also the fourth notes, half note, and so on that are there at the same time. So the problem is that the classical MTTB function is that it will try to find the most important pulsation here, but it could change from one to the other. So next slide, you can see what you are doing now is a kind of we remove some kind of, I don't have time to go into detail here, but it's trying to focus on the fastest pulsations so that then you can see what actually the client is doing, for instance, playing very, very fast. And the final slide is the EFF. So we try to make a release of a public version, a new version with new ways to do in select and browse into music and future works where besides numerical descriptions, it's important to have some kind of structural descriptions of the music as well. I guess I will stop here for the moment. Thank you.
Yeah, coming to the last of the methodical framework, which is the social systems game theory. And this social systems game theory, or short SGT, was basically the answer to the question on how to find a structure in interaction processes and how to formalize actual interaction processes. As many of you probably know, social systems game theory is something that developed out of classical game theory, which is something originally kind of situated in mathematical or economic discourses and is typically oriented to very rational behavior and strategical behavior. So game theory is oriented to modeling strategic interactions between two or more players in a situation defined by fixed rules and given action alternatives and outcomes. And this rather rational way of thinking about interaction is something that doesn't quite lend well to music therapy, whereas in improvisation especially, not every decision is made with high conscience, but rather coming out of emotional or rather expressive necessities. But if we look at sociological approaches, on the other hand, we see that there are provided a language and conceptual tools to model and analyze the diversity and complexity of human interaction conditions and processes, and especially the social systems game theory emphasizing multidimensional action criteria, including emotional and expressive qualities. So by kind of having this development of a game theory that adapts to emotionality and expressivity, we do have quite a fit to, with a good conscience, adapt this model to music therapy improvisation, which is what we did. Without explaining too much on the left side, the interesting part is this right side, which basically differentiates between a role I can act as and the different action possibilities, and stating that one role doesn't correlate with one action possibility, but rather describes a distribution of different action possibilities with one role. Meaning that if we kind of connect this with the functioning of the autonomy microanalysis, we could define that the interaction profiles, so follower, leader, partner, and so on, are distributions of those interpersonally related single musical actions. And the question of how to find those single musical actions is what we can also learn from the SGT, which gives us a structural framework to kind of structure the improvisation into different actions. So if we're having the musical space between therapist and client, we have different musical situations. So situation 0, 1, 2, 3, and so on. And each situation, each musical situation is initiated by a musical action. So if I start to make music, I'm creating a musical situation. And the therapist can do this as well, and this goes back and forth. And our understanding of musical action in this context is musical action as a change in musical behavior. And each of those changes in musical behavior is motivated by a so-called judgment complex, which is basically an evaluation process. Do I like how I'm making music right now? Do I like how the other person is acting musically? And basically based on this evaluation process, I'm deciding for an own action, not necessarily totally conscious, but possibly unconscious on an emotional or expressive level. And this can also be done or is done from the therapist and client side. we can't look into the judgment complex, but what we do have based on the metadata are the actual musical situations and the musical actions themselves. So what we are looking at in this research project are the musical actions, and we do understand, therefore, musical interaction or interaction more generally as the sequence of interpersonally related single musical interactions. Inter is excluded a bit because the actions themselves build the inter between the actions, defined as the change in musical behavior. And all of these three methods together build what we have been calling now the analysis system called CAMI, so computational assessment of musical interaction in clinical improvisation. And this system basically works in two phases when we want to come from this clinical improvisation to the interaction information. Interaction information being the gradients like follower, leader, and so on. And this consists of an analysis process and the synthesis process. So we're delving kind of into the data and trying to synthesize this data back to a higher level for those profile allocations. Starting with the analysis process, we have different pre-processing steps. So of course, we're starting with the MTDB values of the MTDB, and our sample case normally is mean velocity because it's quite easily to use in music therapy contexts. It's quite relevant for therapists to work with, which is why this is typically the sample that we're using. And what we initially did, Olivier mentioned that the step size of the frame is like 1 second, and we decreased the step size to 0.1 second to kind of have a higher resolution on the data and to see more what's happening, especially if we think about reaction times, which are much faster than 1 second. And what we did above this enlarged resolution is to fit a smooth curve to identify trends on this very detailed level. And this smooth data is the data that we are working with in this research project. And now, based on this smooth data, we can apply the segmentation processes we formalized in the SGT, which were changes in musical behavior, meaning changes as increasing and afterwards decreasing, or the other way around, decreasing to increasing one's volume. And we can calculate this actually for the client and for the therapist and layer those over one another, and also look for intersections of curves, because me increasing my volume above the therapist is a totally new action that comes from being affirmative toward the therapist and then being contradictive in the other direction, therefore having two segments as a kind of reinterpretation of the same action. And we can extract these segments and now can try to annotate and characterize these different single musical actions by characterizing data. And this is something that resembles what Thomas said. We have the main deciding factors are proximity, so the distance between the two players, and the relational direction. So if I'm acting affirmatively or contradictively from the other person, so towards the other person or away from the other person. And we calculated for this case relative intensity, the relative intensity of the other player, and the difference or proximity as phi delta %. So the percentage they differ from each other. And we've been training a supervised machine learning classification model to classify each of these segments into the relational direction of the actor, the proximity one, yes, two, no, and the relational direction of the other actor, affirmative, neutral, or contradictive, resulting in a total of 18 different classes and 2 extra classes for if a player is not playing currently at the moment or stops playing or starts playing again. So passages where one is playing solo or if one is not playing at all. So this segment that we extracted, we can look at and we see that the client, so on the upper left side, that the client is moving in his or her velocity towards the therapist, therefore moving affirmative. We see that there is no direct proximity, so they aren't sharing a real close common value with each other, therefore being not in proximity, so meaning 2. And the relational direction of the therapist is also away from the client, decreasing while the client is above, meaning contradictively. Therefore, we would annotate this segment as A2C, so affirmative, not in proximity, while the other person is acting contradictively. And this we can not only do for this segment, but for all of the segments due to this trained supervised machine learning classification model, which we need for profile allocation. if we're looking at the client, we can kind of use this machine learning classification model to translate the original improvisation to a kind of distribution of those interaction types from beginning to end. In this case, on a very detailed view, but also alternatively more abstract, just indicating if it's affirmative, neutral, or contradictive, and in proximity or not in proximity. And then we can implement another slider that goes from the beginning to the end, and for every single situation looks for the distribution of those interaction types and the percentage of distribution of those interaction types. So if we look at the sample that we've been using a minute ago, we can put it through another decision tree that we've implemented, which kind of now classifies this distribution of interaction types to the lastly interaction profile or profile gradient, so follower, leader, and so on. So for this example, we would first ask, what's the prominent action type? In this case, we see that the blue line is the highest, meaning contradictive action is the prominent action type. We can ask for the proximity. We see that there is a solid line, not a dashed line, meaning that it's in proximity mainly. And then we look for if it's kind of balanced with affirmative behavior, kind of indicating more a partner style of playing. But we see here a prevalence of mainly contradictive behavior. And based on these arguments, we would classify this segment or this area as leader type. Alternatively, we can also annotate follower types. We've chosen to implement different follower types. So following from a high distance, therefore not being in this close following situation, close following. We also have dependent, partner, resistor, and neutral action types. Neutral is this kind of extra action type, as no movement is not categorized as affirmative or contradictive, as one can't say if this kind of action now is actually affirmative or contradictive. And we can do this also for this segment and kind of translate this back to the improvisation and annotate this segment in the improvisation as leader type. And we can do this from beginning to end, so having in the beginning more of a resistor and like distance follower actions that are happening afterwards, coming to a close following to the other person. Being in a partner, you see that they are at this point, one second, relatively closely interacting with each other and adapting to the other person quite frequently. And this we can do for basically the whole improvisation and all of an automated basis. So basically, having finished this analysis cycle, we can put the MIDI in and get those results out. In this case, for the client, also for the therapist, I read the right side off a bit because right now we're in the process of submitting these final results again. So sorry for that, but I think you do know what's the emotion of this or the notion of this. And yeah, these are the results of this automation and analysis and synthesis process. Giving back to Thomas, as he knows more about why this is actually relevant in music therapy.
Yes, please, next slide. Yes. Next. Yes. So it's really a perfect moment in time, as I said, because the development of Bastian's tool here, you will see in a second, it is called Kami there, and he taught it also, is now the aim we want really to reach with the high-end project after 12 years of pre-work from 2010 to 2022. Now Bastian developed this tool for musical interaction analysis there of clinical improvisations. In 2010, Elaine Streeter did a survey among UK music therapists, and the majority there said if we want software there for music therapy, we want software that can identify and quantify interactive episodes from music therapy improvisations. And so we can now, and especially Bastian, can provide this here. And next, please. So the background of the music therapy assessment and our International Music Therapy Assessment Consortium, IMTech, is there to develop these assessment tools. And here we have a digital assessment there of musical interaction, and the purposes for clinical practice to apply is we have with this diagnostic assessment of clients in communication, especially on the role relationship there in the clinical improvisation. And so what Tony Vikram did, for instance, in Harper House, when the communication assessment was unclear by medical doctors, then they sent the clients with ASD, with autism spectrum disorder, to the music therapy assessment of Tony Vikram to clarify what communication disorders we have here. And so we have really a tool for the diagnostic assessment of this role relationship in musical behavior. This, for the music therapist, it does also realize also assessment of the needs of the client, and especially in the person-centered approaches or client-centered approaches. It is very important to know the needs of clients also in role relationship in the musical interaction, and it can be assessed here. In this assessment, we can use it to assess also the effectiveness of interventions on role relationship changes there. And this assessment can be used also for clinicians there for as additional supervision tool there to see and learn in the clinical improvisations what are effective and what are non-effective musical interactive behavior of the therapist with the client. So it can support and assist these processes. And so it's a groundbreaking milestone we have here.
Thank you for listening and for taking the time. Thank you for having us. Very shortly, on more information, if you're interested, I've been publishing an article about the theoretical foundations of the system, like in last month in Music and Science. We also have a website that we're currently updating to be up to date, basically. And the next paper, as already said, is hopefully to be submitted in May. We are also present at EMTC 2025 in Hamburg, and do host a High-M symposium in Würzburg, which is hybrid in September. So if you're interested, feel free to register and just write me an email. Thank you.
Yes, thank you very much. That was indeed fascinating talk and fascinating project. And I'm sure there will be a lot of questions. And we can also make sure, while people are putting questions in the Q&A box, that we can put some dates in the YouTube video description, the link to the symposium, to the paper. Olivier, when you release the new version of the MTTB, let us know. We put it, I want to download it, and we can also put it to the YouTube video, of course. And there were also three people who raised their hand instead of putting a question in the chat. So Arthur, Clara, Annie, and Ivan raised their hands. But Ivan also, so Arthur, Clara, and Annie, if you have a question, please put it in the chat. And in the meantime, we can take the question from Ivan. Hello, being here is a great opportunity for me. My first question, besides the media analysis using the toolbox, do you use any other tools or methods to assess musical expressiveness? And the second question, I'm exploring ways to adapt this kind of analysis to open source environments like Python. And what are your thoughts on the possibility of adapting or expanding the MTTB to open source tool platforms?
I think may I start and then you go round there? Okay. So we did focus on the media analysis because we did our first steps there in the music therapy toolbox there. But Olivier is working there also to beside MIDI data, but you can say this then to use this too. As assessment tools, we did really in a way triangulation of the aural assessments there with the IAP autonomy micro and with the outcome step by step we had, and Bastian in the supervised machine learning got there, and we had to refine and to adapt again, and especially he did this. And so we really focused on the musical interaction first. And so I think if you want to have really a good and profound assessment tool in a psychological way, you have to reduce there on very clear questions. And we are happy in the first step. We were afraid, for instance, that we can only analyze following and leading, for instance, there on that way. But we are so happy that Bastian found a model here, a complex model, could include it into supervised machine learning. We had monthly meetings with Olivier to see how to work there in this and to make progress there, and that we can really define and identify all the roles there. This is very important, and so we have to work on this. And the third publication of Bastian will be that we do it really with the MIDI data then of the depression study, the latest, the newest one from Wosch Erkkilä, and there to also assess there in a way, for instance, effective and non-effective music therapy treatments, because we have the medical data, you know, Bastian told this, and we will compare this there. And so these are the steps. And yes, so I hand over to Bastian and Olivier, what you want to add here.
I think especially the questioning about the MATLAB environment, Olivier is possibly best to answer this.
Yeah. So the two questions also about beside MIDI. So we have been also developing a toolbox for analysis from audio, so the MIR toolbox, so that you can also have analysis of aspects that could not be found directly from the MIDI, such as the timbre aspect or roughness and so on. With Thomas, we were at some point considering we were doing some kind of integration of this MIDI and into some kind of new version of MTTB. So that could be possible to take into consideration, but of course the question is how to be able to. It depends. When we don't consider audio, then it depends a lot on the type of instruments, and so you will need to have maybe some analysis focusing on particular type of instrument. But yeah, that's an important question. And I'm happy to use the code of this for the different algorithms. The different features could be made available for if anyone wants to adapt to a different platform. It would be great. And also the version that I will release is a version that can be run without MATLAB. But you need to automatically install some kind of core of MATLAB for free, but it's a bit heavy. So we could consider other environments for a later stage. Yeah.
Okay, thank you. And then the next question in the chat is, and I'm sure many people have that, is how this amazing analysis system is going to be made available to music therapists, and when probably as well. Yeah.
maybe commenting short on that because the development is currently still in progress. So it's still about kind of fine-tuning the results and getting better results and more reliable results and everything. But we expect that like the majority of the work will be hopefully finished by September of this year, and we're planning to, in every case, publish in a standalone version for hopefully easy application in music therapy contexts. But me being not a professional in software development, I don't know how long the process will take from kind of the finished code in MATLAB to having a standalone software and kind of publishing it somewhere. So I'm afraid I can't give a very precise answer on this, but I hope that it's easy to access and, of course, as fast as possible. But I think hopefully end of the year would be a date that I'd be happy with.
I think so. This is the next step, and in a collaboration between Würzburg, Nuremberg, and Oslo, we will work on this when in September we have the really basic tool and how does it work ready. Then they are also for clinical purposes and assessment with the depression example there, and afterwards providing it and developing it for application. Yeah.
And Jonathan had a question about the validity and reliability of these assessment tools. If you could comment on that.
Maybe I can do this as well. And this is, I think, one of the major things that we need to work on to actually have validity in these assessment tools. And this is what I meant with kind of fine-tuning the system to adapt to auditive analysis. And of course, auditive analysis isn't always 100% objective as well. So different people interpret things differently. So what we're trying to aim at is rather of explaining behavior, is rather kind of quantifying behavior and giving data that needs to be still interpreted. So if the data or if the analysis puts out that there is a follower type, we don't in any case want to explain how people behaved without them feeling this. So this is important to kind of check back like the subjective experiences in improvising with the analysis results. And I think this is something that Thomas and I will continue to look at, especially in comparison between manual auditory analysis and the automated analysis results, to kind of close on them as good as possible and to near them so that it's, yeah, hopefully quite valid, yeah.
And Bastian, you had a very high first percentage there on the first results we had.
Yeah, I will have a greater look on this, but yeah, we'll see. I'm optimistic, but I don't want to boast too much.
But it was really high because in 2011 we had percentages of 75 or 80%, and now it's over 90%. And we have also to acknowledge that the aural assessment is very complex, and the digital analysis, as we said, is more in detail. And sometimes so, if you have only articulation or if you have only the volume as velocity there, it is different from timbre or from rhythm and so on. But we found also there is one main feature for each category of the IAP there, and this is also very good and promising we could find here. Yes.
And maybe the last two questions are somewhat related, and you already talked a little bit about that, Thomas. If you want to, or if anyone wants to further comment on that.
Yeah, I think they're quite in the same direction, relating to correlations between depression data. And I think, I don't know, Thomas, if you want to interrupt, but the hypothesis that we're having is that there are kind of certain interaction types that correlate with higher depression scores. So like being more static when having higher depression scores, and being more fluid and having more styles of play available when having lower depression scores. But we actually didn't already correlate those depression scores with the analysis data. So this is also something that we're doing in the following months, and where we hope to have some kind of correlation that tends, or that possibly
you have to wait. A first look seems to hypothesize in effective treatments leading increases, but we please wait until September, then we can give the answers there. And Ming is also yes. Yeah, the artificial intelligence analysis is a supervised analysis. So it is framed and structured by the aural analysis and annotations there. So it is not, it is not the result of the computer. The computer was taught by humans. And so there. And of course, we have really the focus just on musical interaction. And in September, we can say what there will be in relation to depression severity. Yeah.
Okay. Do you want to say something to the last question, I would say, because given the time, about more future directions of the technological development and the analytical platform analysis in real time, for example?
Yeah, maybe I can comment shortly on this. I don't know, I need to look more into it if real-time analysis is possible, and have these running this alongside improvising by itself. But I think, if I understood correctly, implementing this in generative artificial intelligence would be highly interesting. And actually, one of the cooperation partners of us, so Sebastian Vobig from the University of Music in Nuremberg, has like a professorship also for generative AI for music. So the idea is also to have like kind of, I think you also mentioned this, like game theoretic settings of kind of drawing sheets of paper where one needs to fill a role kind of, and testing if you can teach a computer possibly to inherit one of those roles and all the time act as a leader while at the same time acting as a follower in velocity. So this would be very nice to have this possibility of teaching this again to an AI, and to kind of play around with it more and work with it more in those experimental and game theoretic settings. Yeah.
So may I say three very short thoughts there. The one is again on the interaction analysis and depression. We did IAP-AM there in the first depression study with Jaco, and we found changes in musical interaction in effective depression treatment, because this treatment was very successful, and there we had changes in the musical interaction. And now we just want, because it's time consuming, 1 to 2 full-time weeks, you need 40 to 80 hours for a microanalysis of clinical improvisation, and to transfers this to the automatic analysis. This is the first. The second, it is assistive technology. It is not the truth pure. It will assist, but it gives a lot of very important and useful information there, and you can repeat it. So they will really assess the same thing as the same things. This is very important. And the last one is, of course, the dream to analyze also wave data with this, but we are going here into very details, and so far we can do it very well there with MIDI data, and we have to find ways what lighter versions are acceptable and will identify these very detailed changes of 0.1 second changes. There we analyze here there of 20 musical features, different categories there, and to make a part of this work also for wave data. And so with 2 microphones to tape, it would be applicable for all clinical practice there.
All right. Great. Thank you very much again. It was a very good lecture, fascinating work. We try to wait patiently for your next publications and outputs. And yes, and thank you everyone for attending. And I think Leo has some announcements to make for the next public research lecture.
Thank you, Clemens. Thank you so much to the 3 of you. Fascinating research and exciting futures. We are inviting you all to join our newsletter so that you can be aware for our next CIMTR lectures. Our next one is with Dr. Guillaume Dumas on the 16th of June about hyperscanning into brain synchronization and its clinical applications, which has a link, maybe the neuroscience link with this work. So thank you so much for joining us. Make sure to complete the survey once you quit this Zoom link, and we will see you very soon.